What's up, guys? So welcome back to another video. Today we're going to be doing this exercise over here. It's about, obviously, the resource allocation graphs. So what are the resource allocation graphs? Are basically just a graph that can help you to find resources and allocations. That's why it's called resource allocation graph. So an example of this can be seen, for example, let me just try to find it real quick. If we go to our lecture notes from our class, I'm pretty sure we can find it here in deadlocks and scheduling here. If we go back here, we see the rate systems and everything. We can keep going and find the actual deadlock. So here's a deadlock. As you can see, this is a RAG. And we have a resource 1, resource 2, and resource 3, and resource 4. And each of these we have different instances of it, you know. And then we have the processes as little balls or nodes. And the processes, whatever they go, means it's asking for it. For example, P1 is requesting one of R1, right? And P1 has one instance of R2. So let's go back to our IBN item. So we can make it's asking us to do a deadlocks of detection. Well, yeah, we're asking for to draw a RAG for each of the two situations. The RAG contains a cycle and a deadlock exists, and the RAG contains a cycle, but a deadlock may or may not occur. So let's go ahead and do the first one, right? Right. So in this case, I'm gonna make 3 processes, so to speak. So P2, P3, right? We have 3 processes, and I'm going to have 2 resources, so to speak. So let's go ahead and do resource 1. We can have 2 maybe, or 1, simply 1. And maybe I can have, 1 here, right? And what we can do, maybe we can have 2 actually. Let's see. And let's create a cycle in which P2 and P1 have the following resources, and then P3 has another resource. So what I'm thinking is, right, this will be actually, let's just create the following. Just remove this. It contains a cycle and a deadlock exists. So in this case, this is going to be basically where a deadlock exists. So we're going to do here, P1 is asking for R1, but R1 is already given to P2, right? And P2 wants 1 of R2, right? So we have 1 already taken. Sorry, we have 1 already taken here. And P1, P1, what we can do is the following, is this. So in this case, P1 wants R1, but R1 is already taken by P2. Same thing for P2. P2 wants R2, the one instance of R2, but it's already taken by P1. So over here we have a cycle in which we have a deadlock, and we cannot go further than that. However, we can go for the second instance, and it says here the RAG contains a cycle, but a deadlock may or may not occur. So in this case, what we can do is the following. Hold on, let me just duplicate this. This is going to be quite similar to our actual exercise here, but we're going to do the following. We're going to do a P3, right? A P3. P3. So for example, what I'm thinking is, right? Let's remove this dot so we can have them actually given like so. And we can have it like so, right? So what happens here? Well, first of all, P1 is asking for P1 is asking for R1, but both of the R1s are already taken by P2 and P3. So let's go see what happens with P2. P2 is still asking for R2, right? So it will not release R1 unless he gets R2. And then P1 will do the same. He has R2, but will not release R2 unless he has R1. So there's a deadlock, so to speak, here. However, what happens with P3? P3 has no requests. He's not asking for anything. Meaning, once P3 is done, let's say he is done with the resource, like he makes the process and he's finished with everything he has to do, he releases R1, right? He releases R1. So finally, P1 can get R1, right? And he can finally release R2, so to speak. And then finally, P2 can get R2. So in this case, that will be a deadlock in the initial state. But once P3 is done with his thing, he can release R1, and then the cycle can continue and be released. So that's pretty much the gist of this idea. Again, if you're confused about the situation, I would suggest you to look at the Folien, page 31 of, I think it's lecture 16. I'm pretty sure. No, 15. It's lecture 15. Go to page 31. And over here, the same situation, right? It's the same situation in which we have no deadlock. Why? Because, well, there cannot be a deadlock as long as P2 and P3 are independent here, and P4, sorry, this will be released. So it's the same case in this scenario, right? So again, I think that's pretty much it for this exercise. We're going to be doing 3.4 and 3.5. I think we have 3.5 as well as an exercise in the next videos. So again, thanks for watching, and I'll see you in the next time.